In this video, we're going to do a chromatography demonstration that's going to utilize a polar stationary phase and a less polar mobile phase. So I've got my equipment out here and I'm going to show you how I construct this. This is actually a technique you'll use oftentimes in organic chemistry labs, research labs, when you're trying to determine what concentrations of solvent would be best used in a silica gel column to separate multiple compounds. And so we're going to make essentially a mini column for column chromatography. And we're going to do that using a glass pipette. I have a little piece of cotton here that I just pulled off of a cotton ball. And I'm going to use a cleverly crafted, paper clip. And I'm going to try to push this down. And I'm putting this cotton in here just to create a base so I don't have my silica gel fall out. And so it's just kind of like a little plug. So that way the silica gel has a kind of a landing spot. But all of our compounds will be able to go right through it. All right. So here I have my column with a little bit of cotton. Now I'm going to fill my column with my stationary phase. That is going to be my silica gel. So I'm going to kind of set this here. I'm going to use a funnel. I'm going to set this in here just to stabilize it. What I have is silica gel that's a 60 to 120 mesh. This is really just a very fine grained silica that's like a powder. And it, that I actually honestly just got off Amazon. It's like lab grade. So I'm just going to put a little bit in. I'm not going to worry about an extremely long column. And so you can see I've filled that silica gel. And now I have a column for column chromatography, a really small one. And so what I'm going to do is prep this column and fill it with the solvent that I'm going to use in the experiment, and which is going to be something that is less polar than water. We're going to go with a 90% isopropanol solution. So it's 90% isopropanol, which is an alcohol. So it's self-polar, and water 10%, but isopropanol is much less polar than water and has a lot less hydrogen bonding capacity. And it has, lots of carbon and hydrogen bonds. So I am going to kind of set this up. I'm going to use these little test tubes to catch my solvent. So what I'm going to do is very carefully add my isopropanol kind of dropwise so it layers on top of the silica gel. And again, this is just preparing my column. I can let this move through the silica gel by gravity, which will kind of happen a little slowly, but not too terribly. And it'll slowly then drip out. I can also give this a little helping hand with a pipette bowl. Let me show you what this is going to look like right here. And what I'm going to do is just place it over the top very carefully and give it a little bit of pressure. And then you can see the solvent is going to move through it a little faster. So it's kind of like high pressure column chromatography. I'm going to be really careful not to pull this bulb off suddenly, so that way I don't make this kind of a mess. I'm going to do this until all of my 90% isopropanol is in the column and there's none at the top. Because the next step of preparing this is going to be to load it, is one phrase. And so what I have is a very concentrated solution of grape Kool-Aid mix with just a touch of water. And I wanted this to be as concentrated as possible because I'd like to get away with just using a couple drops of this. And so I'm going to put this on the top of the silica gel. And I don't want to have a lot of volume because this is dissolved in water. All right, so I'm going to put 3 drops. And you can see that dark color, so concentrated, it just actually looks black right there. And so now, you can see I have my compound I want to separate right here, the purple Kool-Aid that's very concentrated. And I have my silica gel that is filled with isopropanol. And now I am going to put more isopropanol on, layer it on top very carefully so it doesn't mix too much, and then push it through. And we're going to see what color elutes first. So it's either going to be probably blue or red. I have lots of different test tubes here to allow me to collect different colored fractions. So right now, just clear is coming through. I'm starting to see the color come up. So I'm going to switch and collect. Now I'm going to switch and collect again because it looks like it's turning a slightly different shade of blue or purple. All right, I see it getting light again. So I'm going to, once I start to see this color change, it's very light now. I collected this fraction right here. It might be easier to see this color right here as a nice light blue. So now I'm going to keep going, and I'm actually going to switch to a different solvent. So that was with my less polar isopropanol solvent. And now I'm going to layer just a touch of water. Actually, let's do another layer of isopropanol. Just show you what that's going to look like. So it's just coming out clear. There's a little bit of blue color to it maybe, or purplish color. Which tells me that maybe there's a little bit more red now in the solution, but it's really light. Okay, so we didn't get anything. We got that purple color out. Now we're going to do water. So what we're doing is we were using a less polar solvent, right? And now we're going to use a much more polar solvent, water, through our column, and we're going to see what color comes out. Again, applying some slight pressure. You can see how there's actually now, you can see this. There's like a brownish red, a rust red, and then kind of a magenta, then another layer of blue coming behind it. Because some of the dye stayed on the top of the silica gel. Might have actually been a little bit of solid, honestly. And here comes our red color through with our water. I'll stop there. So here we have our first color that came out was blue. And the second color that came out when we added the water was red. In between the two, our second fraction of isopropanol was a reddish purple. So just using a polar stationary phase with a less polar mobile phase, we were able to have a blue color come out first, followed by, I don't know if you can see it very well. Let me get a piece of paper, followed by like a reddish purple. And then when we added water, we were able to pull out the rest of the dye. And so when we added water, we had a polar stationary phase and a polar mobile phase. I'm actually going to dilute this, hopefully, so you can see the color a little bit better. Not sure how that's showing up, but it looks like a blue to me. And then we have what came when we put our polar solvent through our polar stationary phase, red. So we have blue come out first, followed by red when we have a polar stationary phase and a less polar mobile phase. The red came out when we then used a more polar solvent. We had more red come out.